Hey everybody, thanks for tuning in to this edition of Walk Through a Quest. Um, all of the problems that I'm going to work through are going to be from Quest A. The numbers are going to be a little bit off here and there, but all the questions are the same. So I just wanted to say that right at the beginning, so let's get started. First of all, we have this equation, 48 equals 8 times y. So first of all, remember that 8y means 8 times y. So we're looking for a number that will solve this equation, will make this equation true, right? So this side would be 48 and this side would be 48. If you think about it for a second, we can reason that this must be 6, right? But right now it's about making good habits, right? So this is the test part of it. We should be well established in our good habits, that good habit being that whatever this number is, right? This number is 8 times bigger than that number. So what I want to do is divide both of these sides by 8, right? And so 48 over 8 is 6. And indeed 6 equals y. Let me just, again though, justify that 8y over 8 is y, right? It's not magic, it's math, so let's look at the math of it. We have 8y divided by 8. I can write that as 8 over 1 times, let's see, 8 over 8 rather, times y over 1. Okay, in case you're wondering if that's allowed, we just multiply these two fractions together. 8 times y is 8y, 8 times 1 is 8. And 8 divided by 8 is just 1. Y divided by 1 is just y. So what we really have here is 1 times y, which is the same as y. So definitely if we have 8y and we divide by 8, the 8's cancel, quote unquote cancel. All right. Here we have a negative x over 4 equals 16. Right. So you know what I might want to just do just to clear things up real quick is just multiply both sides by negative 1. Negative 1 times negative thing is positive that thing, right? So x over 4 equals 16. Sorry, negative 16. That's better. And now I don't have to worry about the negative. Now, what about this x divided by 4? What am I going to do about that? It's a very similar situation as this was. We want to get this 4 to get canceled out, to use a term I don't love. If we multiply it by 4 over 1, multiply by, well, we could just multiply by 4 on this side. Let's see what happens. Well, 4, let's talk about this over here. 4 over 1 times x over 4. Does that indeed cancel these 4's? Let's be absolutely sure. Well, let's multiply these two fractions together. We get 4x over 1 times 4 is 4. I split them apart again. I get 4 over 4 times x over 1. Okay, 4 times x is 4x. 4 times 1 is 4. I can split these apart as 4 over 1 times x over 4 as they were to start with. 4 over 4 is just 1, and x over 1 is just x. So 1 times x is x, so this side is definitely x. So that's great, and whatever's on the other side, that's what x is, because that's what this is saying so far. And negative 16 times 4 is negative 64. Now, if we don't want to take two steps there, we could have taken negative x over 4, multiply it by negative 4 over 1, take care of the negative and the 4 at the same time, and then 16 times negative 4 would also give us negative 64. Okay. And in one step here, we'd have negative times negative is positive, and the 4 divided by 4 is 1. There we are. All right, so here we have a 6/7 times x, but we don't want 6/7 times x. We want, as in the last two problems, to have a 1 times x. Is that possible? Can we have a 1 times x? A lot of times I hear divide by 6/7. Absolutely 100% correct. I like to write that very thing just slightly differently. I like to write it as times the reciprocal, times 7/6. What do I get here? I get 42 over 42. That's 1 times x. That's 1 times x. That's x. So we'll just multiply this by 7 over 6 as well. Okay. So from all of this discussion, it should be easy to believe that I can justify rewriting this fraction, this product of fractions is this product of fractions. 126 divided by 6 is 21. times 7 is 147. All right, here, a lot of people want to divide by 10 here. We've been over and over and over it, and people still want to divide by 10 right now. You certainly could, but remember you'd have to divide this entire side by 10. Okay, it'd be like having a scale and having some stuff, right? Some stuff here and some stuff over here, having some stuff over here, and saying like, oh, I'll just take this and I'll cut it up into 10 pieces, right? And then just look at 1/10 of it, but not cut this into 10 pieces, okay? You need to have 1/10 of all the stuff over here, and since it's all balanced, 1/10 of this stuff, including this, okay, so I'd have to divide this in 10, which is a little bit tricky. Okay, that's kind of divided in 10, and then I get 1/10 of this part and 1/10 of this part, and divide this in 10 as well, right? So what I'm showing you is that you have to make sure that if you divide by 10 right now, that you divide everything by 10, every part of the left side and every part of the right side. Okay? To say it a little bit differently, you have to divide each term. Terms are separated by addition and subtraction. Each term by 10. So this problem would now look like x plus, let's call it 0.2 equals 9.2. All right, and then we'd have to subtract 0.2 from both sides and get x equals 9. I don't really like that. What I like is, instead of dividing at the beginning, okay, how about save it for a second, subtract 2 on both sides. Right, get rid of that constant on this side. Get 10x equals 90, then divide by 10. Because then over here, all I have is 10x. It's the only thing that has to get divided by 10. Right? And still, x equals 9. So 7/6y plus 14 equals 25. We're going to approach it very similarly to, I think, yeah, just this last problem we did. Let's get the constant off of this side. Let's cancel it out by subtraction or addition, whatever the case calls for. And then cancel out the coefficient of x, the thing that's multiplied by x. So here we go. Let's subtract 14 from both sides. Get that out of there. 7/6 y equals 11. All right, and just like the problem I think just before that, right, we have this fraction here. We don't want a fraction times x, we want a 1 times x, so we multiply by the reciprocal. Times 6 over 7 times 6 over 7. We could make that 11 over 1, so it's easier to think about. And y equals 11 times 6 over 7. Here, well, if you just forget about this side for a second, here we have just an expression that needs to be simplified. We combine like terms. Negative 5x plus 8x is 3x. 14 plus 7 is 21. Equals 13. And now we have a problem just like number 4. We're going to negate this constant here. 13 minus 21 is negative 8. Divide by 3. X equals negative 8/3. Okay, here we have another equation, and cannot resist the temptation to distribute this negative 4, so I'll just go ahead and do it. Minus 12n plus 48 equals 13. Now we have like terms, we can combine those. That's going to be a 6n plus 48 equals 13. Bringing my work over here. I'm going to subtract 48 from both sides. 6n plus 48, no, you just cancel out that 48, equals negative 35. Divide by 6, and n is equal to negative 35 over 6. Alright. We have a question about averages. Remember, averages, we take a number, and we add another number, and we add another number, and we add another number, and we just add up all the numbers until we've added them all up. and then we divide by the number of numbers. In this case, there's 1, 2, 3, 4, 5 of them. We would divide by 5. There you have your average. So the question here says, your last 5 basketball games, you scored 5, 8, 3, 12, and 7 points. In order to average 8 points per game, how many points would you have to score in this upcoming game? So this upcoming game makes 6 games. So we would want an average out of 6 scores, right? So we're going to divide by 6. We're going to divide the sum of 5, 8, 3, 12, 7, and our next game. And when we add them all up and divide by 6 and find the average, we're going to find that the average is 8. So what will this guy here have to be? We could add these together, and those add together to 35. Now what do we do about this 6 here? Well, if we multiply by 6, you kind of go backwards this way, we can write it as 6 over 6 times 35 plus x over 1. 6 over 6 is 1. 35 plus x over 1 is just 35 plus x, right? So that gives us 35 plus x equals, of course we have to multiply by 6 on the other side. 6 times 8 is 48. Subtract 35 from both sides, and we find that x must be 13. So you got to score 13 points, more points than you have scored in the previous 5. You got to do 1 better than your best game so far in order to average 8 points. Okay, again, mom and dad loaning you money, or giving you money to buy this car. You're working, you're picking up money wherever you can find it to add up to this $1,700. That's how I saw lots of different equations. This is the equation that I think of. All this money has to add up to $1,700. So I just add up all the money that I have or will have, and it has to add up to $1,700. So I start with 1,600, or not 1,600, 600. Right? That's easy. That's just a dollar amount. Here's another dollar amount, $77 from mowing lawns. All right. Anything else? Any just spare money floating around? No. Well, then I have to add on the money that I make from working. Well, I work 21 hours and make $11 an hour, so now I'm going to do 11 times 21. But I also know that I could just add up all my hours, 21, 20, and 27. Whatever the sum of all those hours is, I'm going to multiply it by 11. So that's going to be money that I've already made, plus the money I'm going to make, and I'm going to make it in the same way as I did here. I'm going to work some hours and get paid $11 an hour, and 11 times the unknown, yet now unknown number of hours will be how much money I get paid for those X hours. So let's grab our calculator and see how much money we have so far. So 21 plus 20 plus 27, multiply that by 11, that's 748, so this is 748, plus 70, well, I guess we'll just say plus 677, right, so we'll just say plus 677, so 1425, so the money that I will get plus the money that I already have needs to equal 1,700. Some of you started with this equation, and that's perfectly fine because it's all your work to get there, right? And this is a good equation. You don't have to write it exactly like that. Some of you had an x inside the parentheses. Great, that's absolutely true. So now we have a problem just like I think it was number 4, where we're going to want to get rid of the constant on this side, and if we subtract 1425 to make that possible, we need to do that on the other side, otherwise the scale is going to be all out of whack. 11x equals, I'm going to subtract 1,700, and just know that my answer is going to be a positive version of this, 275. I'm going to divide this by 11, and again, remember that it's going to be positive, so x needs to be 25. 25 hours, that's how many hours I have to work, which is not as many as the most hours I've worked so far, but it's a lot, especially for a student. solve this equation. We've got variables on both sides, right? We do not want variables, say, on this side. Say I don't want variables on this side. How can I not have variables on this side? Divided by 5 won't do anything because, well, it's already faulty reasoning, but 5x divided by 5 is not nothing. It's just x. So I still have variables on that side, right? If you think about it, on this side of the scale, I have 8 things, 8 x's, and here I have 4 1's. On the other side, I have 5 x's, right? This is 2 sides of the scale. I have 5 x's over here, and I have 25 of those things. Right? And the way a scale works is I need 1 x over here, one unknown quantity over here, and then a bunch of these guys over here, and when they're balanced out, then I know how much an x is worth. So the first thing I want to do is not have these on this side, right? And so I'll take this one out. Oh, but now this side is heavier, so I'll take this one out, and now they're balanced. I'll take this one out, and I'll take this one out. Now they're balanced. Take this one out. Now this side's heavier. Take this one out. It's the same. Take 2 of them out. Take these 2 out. What did I just do? I just took 5 x's from this side, and took 5 x's from this side, leaving 3 x's on this side, and no x's on this side, right? If I were to look at the equation, I've just taken 5x from this side and 5x from this side, left with 3x plus 4 equals 25. That's good. So we have just x's on one side, and now it looks just like number 4 from this very quest. We'll subtract 4 from both sides, and 3x equals 21. Divide by 3, and x equals 7. Here we have multiple variables, all with different names. We just want to get x by itself. But we do the same thing in the situation if this was a 4 and this was a 12, right? If these were specific numbers, we would do the exact same things right now. For instance, I would subtract whatever this number is from both sides so that it wasn't there anymore. 3 plus x equals whatever f minus a is. Bring my work over here. I'm going to give in to the urge to distribute the 2. I think that's probably the most common thing people would do here. Then we'll subtract 6, right? Let's get rid of that guy. We have f minus a minus 6. We'll divide both sides by 2, and so x equals f minus a minus 6 over 2. Here, number 12, we are going to solve for q, so we're going to get that guy by itself, right? But we want to not divide right now. We're just going to hold off on that. Let's get rid of this, just like we got rid of here. Just like here. This equation is a lot like this one. This is 3x plus 4 equals 25. If something times a variable plus a constant equals a constant. Only this thing right here, it's not a constant. It's just another thing with a variable in it. But we don't care about it. We want it gone. We want it completely wiped out. So we'll subtract it from this side, right? It's being added, so we'll subtract it, and that will be 0. And we'll subtract 15n from this side, and we can't combine these together, so what we can do is write that 10q equals 49 minus 15n, whatever that is. Now, just like in this situation, we got rid of this thing that was being added on, and now we'll divide by the number that's being multiplied by x. We divide by 10. 10q divided by 10 is q, so q is equal to 49 minus 15n over 10. Okay. Number 13. We got variables here to combine, right? We got things to combine. We got variables on this side. We got all sorts of stuff going on. So to start with, I've got things that are the same on this side, the same kind of thing. So I'll combine them. 5x minus 2x is 3x. 14. Oh, there's no other numbers over here. So just 3x plus 14. I was playing tricks on me. Thought the 9 was over here, but it's on the right side of the equation. So we got 9. Negative 2 times 4x is negative 8x. Negative 2 times positive 2 is negative 4. Now we have variables on both sides. We would like to not have variables on both sides, instead have variables on only one side. So I'm going to add 8x to this side. Negative 8x plus 8x is 0. Bring my work up here. 8x plus 3x is 11x plus 14. I'm going to take 9 minus 4 and get 5. I'll subtract 14. 11x equals negative 9. Divide by 11, and x equals negative 9/11ths. One video rental club charges $50, 99 cents a video. The other charges $3, no fee up front. Okay, so at this first place, how much would it cost me to rent one video? Well, $50 plus 99 cents for the one video, $50.99. How much would it cost me for two videos? Well, $50 plus 99 plus 99 more, so $1.98, so $51.98. Right, you start to get the idea. We're always going to have $50 that we spent to join, plus 99 cents times the number of videos that we rent. This guy here, this is just going to cost $3 a video. So $1 or one video, $3, two videos, $6, three videos, $9. No 50 or any amount to add on. It's just $3. The amount that we spend is for the first place is equal to this expression. The amount that we spend at the second place is equal to this expression. We want the amount that we spend at one place and the amount we spend at the other place to essentially be equal to each other. And once they're equal to each other and go a little bit past that, then this guy will start to be a better deal. Because it doesn't take long for you, for a little investigation, for you to understand that for a small number of videos, I want to go to this place here, right? Because for one video, this is $50.99, and for one video, this is $3. Just obvious comparison. Two, we already said this would be $51.98, and this guy would be $6, right? This is much, much cheaper, but you'll notice this one only went up by 99 cents. This went up an entire $3. This one's growing really fast. This one's growing really slowly. This is like a car that starts off way behind, right? Its distance is smaller, but it's driving much faster than this car. This car is just kind of putting along. This car is eventually going to catch up, right? When does it catch up? 3 videos, 4 videos, 10 videos, 20 videos, 30 videos? Where does it catch up, right? And then, once it's caught up, they'll switch, and this one will always be behind after that point. So, to solve this equation, we have variables on both sides. We'll subtract 0.99x from both sides. 50 equals 2.01x, very important, that 0.01. Divide by 2.01, divide by 2.01 on both sides. Let's find out what that is. 50 divided by 2.01, 24.88. Okay, so x is about 24.88 videos. If I could rent 24.88 videos, then I would spend exactly the same here as I do here. But I can't rent 24.88 videos, and I don't even want to spend the same at both places. I want to spend less here than I do here. At that 25th video, this is going to be just a little bit cheaper, right? At the 25th video, let's see how much both places cost. 50 plus 25 times 0.99. This place is going to be 74.75. In this place, 3 times 25, that's pretty easy. That's going to be 75. Right? So they just switched, just barely more expensive here, 25 cents more expensive at this place. But after that, it's going to be always more expensive after 25 videos. So 25 videos. That's the x that makes the first place a better deal. And here we have an equation like number 3, maybe it was number 4, where we have a fraction times our variable to be isolated equals, it doesn't really matter what it equals, because we just want to get it by itself, right? So we want a 1 times b, so we're going to multiply by the reciprocal 8/5. And then we're done. B equals whatever 8/5 times y is. And the last one, solving for y here, which means we want to get y by itself. It might help you to look at this as negative 5y plus 2x equals 5. I've just kind of flipped these around, changed the order a little bit. But we, a lot of times, see our variable that we want to isolate plus something else or minus something else, and then equals. So just to put it kind of in that left to right structure, we can read it right it that way if we want. And this way we can clearly see that something is being added to our term with a variable in it that we want to get by itself. So, since something is being added to the thing that we want to have by itself, we will subtract that very thing. And we'll have negative 5y equals 5 minus 2x. And now we have a negative 5 times y. How do we counter the multiplication of a negative 5? We divide by negative 5. So we have y equals 5 minus 2x over negative 5. And that is it. Thank you for watching, and if you have any questions, please don't hesitate to ask.